Good morning, everyone. Welcome to 8th International Artificial Intelligence and Data Processing Symposium, and welcome to our keynote session. We are very happy since this is the 8th IDAP, and without your support, we wouldn't be able to make it. Thank you so much again for everyone. Special thanks for every respected researchers around the world who contributed to IDAP 24. As you know, without your interest, we couldn't be able to make this event. We congratulate the authors of all accepted papers. And also, I would like to thank you, our chair of IDAP 2024, Dr. Selman Yakut, for doing entire work, managing, organizing, and involving entire duties of until to this day. And also I would like to give a special thanks for the people who have been working to organize this event. In addition, I would like to express my special thanks to IDAP Honorary Chair, Professor Ali Karcı. As I mentioned, this is 8th IDAP. He has been inspiring, guiding, supporting, and sharing his experience since many years. Special thanks to him. And on behalf of IDAP Organization Committee, I would like to express my sincere appreciation to Dr. Mugahed Antari for accepting our invitation to become our keynote speaker of the 8th IDAP Symposium. Dr. Mugahed Antari is currently working for the Department of Artificial Intelligence and Data Science at Sejong University in Republic of Korea. Dr. Antari received his PhD in 2019 in biomedical engineering from the College of Electronics and Information at Kyung-hee University, Republic of Korea. And Dr. Antari has more than 7 years of teaching experience in departments of biomedical engineering, artificial intelligence and data science and software. And also, he currently leads domestic and international projects, collaborative research projects funded by the government of the Republic of Korea. And also one of the international projects is collaborated with Turkey. Thank you so much for this. Dr. Antari has been published more than 100 conference and journal publications. His research interests include explainable AI, deep learning, machine learning, pattern recognition, medical signal and image processing, and medical imaging of dual X-ray absorptiometry and AI-based NLP for healthcare application. Dr. Antari has been a member of IEEE and IEEE EMBS since 2014. Also, Dr. Antari has been recognized among the top 2% of scientists worldwide in 2024 researchers list compiled by Elsevier and Stanford University. I know you are waiting to listen Dr. Antari's keynote presentation. Dr. Mugahed Antari, thank you so much for again participating in our event. And now stage is yours. You can start your presentation.
Okay, thank you so much, Professor Ahmed Arif. First, I would like to thank all of you in IDAP conference, since it gives us a very good chance to meet all of you guys and start to talk about the recently research topics, which is XAI based on LLM. So today we will study these topics. Can you see the screen moved in the your side, Professor?
Yes, we can see.
Okay, great. So I will talk about the explainable AI in healthcare as an introduction, and then we have to ask ourselves what is the motivation behind XAI, especially for medical application, right? So then we will talk about how to combine these XAI with LLMs and how to improve the prediction and diagnosis at the end. So for the patient as well as for the medical staff who will interesting to improve their skills as well as to provide a very good reports to the patients. So at the end, the patients will receive diagnostic information, recommendation, as well as visual explanations based on the XAI modeling, plus the explanation in terms of textual reporting based on the LLM capability. So recently, we will talk about the LLMs as a supporting technique for XAI to make the diagnostic more accurate and also generate some reports at the end. And for sure, even if we have LLM and XAI, still there are some challenges, and we will introduce some future directions for future applications. And then we have some conclusion about these topics. So as you know, the existing XAI is coming based on different capabilities in the AI technology. So if we define this XAI technology in terms of capabilities, functionality, technology, and learning, we can see at the beginning, we have some narrow or weak AIs that cannot explain anything. And then we will extend to the general or strong AI. So in this stage, based on the capabilities of AI, we can say XAI can fill in this gap of general or strong AI. That means we need to generalize the output of AI to make it more strong for even doctors and as well as the users or patients. And for future, we are still waiting the super intelligent AI that can reach to the human level or maybe exceeds. And this is our goal based on the Google CEO explanation last month. So XAI will fall also in this category. Based on the functionality, we have reactive machines, limited memory AI, theory of mind AI. So in this category, XAI start to be available, I think starting 2019. DARPA introduced XAI in a very big conference. I will introduce in the next slides based on. And we have also self-aware AI. That means it is updated by itself. It is learning by itself. It is the basic technology for this. It is reinforcement learning as well as LLM to generate more information for both doctors and users. Based on technology, AI started from the symbolic AI, which is based on the rule-based, if or else, and then come to the connection AI, which is based on the machine learning and deep learning that we already know these days, CNN-based or even transformation or transformer, vision transformer, VIT. Then evaluationary AI, it comes at the end, then it will cover all the topics before, then even if it is a single modality or hybridization, to cover even explanations based on the visual explanation, heat map, saliency, or shape figures. And then it will provide some explanation based on the NLP processing of recent technology of LLMs. So if we saw that in terms of learning, then XAI can improve the capability for supervised learning. As we know, we have different techniques for example, object detection, segmentation, or classification, and other computer vision techniques. And also unsupervised learning, once the data labeling is impossible or difficult to be available. And semi-supervised learning, self-supervised learning, reinforcement learning, which is based on the future. We will focus on reinforcement to make these machines self-aware and increase the level of thinking to be in the human phase or human phase. And transfer learning for making XAI more robustness. And XAI can incorporate with each of these techniques to improve the results of diagnostics and make it more accurate. So in terms of marketing revenue of the explainable till 2013, based on some studies from USA, so we will see starting 2019, XAI start to be a pair after this covering by DARPA, which is the defense community in USA, and then it will start to increase. So the prediction till 2030, it will be in terms of leading in this AI technology. So XAI is also not applicable for medical things, but it is also for different sectors in our research. So we can use it for fraud detection or renewable energy as well, social media, and predictive sum management systems. So all of the people now are targeting XAI as a state-of-the-art for research. So in terms of future for AI healthcare, so we can start to analyze this technology, even domestically in Korea or globally, Turkey and other European countries, USA, right? So we are always tracking this kind of smartness in the AI, XAI, and this revolution that happened recently based on LLMs. Once the GPT is started, to be in our face and use it, right? So our purpose in this lecture is to show how can we integrate LLMs with the XAI to improve not just visual explanation, but also textual explanation. So textual explanation based on LLM. LLM is, at the end, is the NLP techniques that can provide some interpretation or some explanation in terms of chatbot questioning, answering, or, for example, in terms of report generation, as what we have example today. So also, if we thought about XAI, it came in the third wave of the AI developing strategies, and these three waves that is starting from before 2000, and it was the first wave. It is called described symbolic reasoning, and in that time the preserving it was very low comparing with the third wave XAI. So here, if we compare between perceiving in the first, second, and third wave, third wave, it is our explainable AI modeling that is appearing recently. Second wave, it is based on the machine or deep learning CNN or transformer. So we can start to see the abstracting, which is the feature generation and how much these features are very rich to represent the object. So it started to be in the second wave to appear, but still it was very limited since we have a black box for CNN, for example. But for explainable, the abstracting for feature extraction and make a decision based on the reasoning of these XAI models, this can provide more information to the models and can provide benefits for doctors as well as users. So the convenience will be very confidential. It will be very high. So if we compare abstracting, which is the feature-based extracting, the first wave based on the symbolic AI because it is rule-based, if and else, then abstracting was nothing. After we come to the second wave of CNN and transformer, then it starts to increase. However, with explainability, we can say that the abstracting and reasoning features, it is somehow increased. And these two features for XAI modeling, the benefit of them is to improve the diagnostic and make it more trustable and true for the doctors as well as the user. So these are some explanations about what is the meaning of perceiving, learning, abstracting, and reasoning for each of these waves. And nowadays we are working in the third wave. So third wave is based on the explainable AI models. And we are awaiting the fourth wave that is talking about something integrating XAI with LLMs. And the people and researchers worldwide now working on, and we are trying today to deliver something in this area. So the concept of XAI, as you already know, that we have some limitation with the current or second wave of deep learning CNN or even transformer models. They have black box to generate such kind of features, and the output always, it is our question, why the model give us this kind of answer, right? So always we are asking this question, we are asking ourselves as engineers before doctors. However, doctors, they trust our AI models based on the communication continuously with them. And we have always to provide them more information. Not just we can say the output is diagnostic or it is true or false, normal or abnormal, but we need also to give them more information to explain why this decision is happened by this modality, right? Whatever the CNN model has been used, we have to always give more information to make some convenient or some trust worthy between us as engineers as well as doctors in hospitals, right? So first, we were very happy that CNN become to our face, and we can build models to generate very high deep features, and then recognize the models based on the AI tasks, detection, segmentation, or classification, or sometimes translation in terms of transformations, right? So recently, in starting 2019, explainable interface and explainable models start to appear and to give us a chance to give more information to be convenient for doctors as well. So in fact, these XAI models can give us some explanation for us first to be trust this kind of black box models. And based on explanation from DARPA in 2019, they start to make everything in the visual heat maps. For example, in image processing, the XAI models can generate only heat maps, right? So after LLM comes in 2023, so everything start to direct it in how to integrate this LLM with these explainable models to also give some explanations in terms of text. So we can call this one text explanations, and the XAI models that generated by DARPA can give us heat maps or visual by eyes. We can also recognize these kind of outcomes. So explainable route maps, we can categorize them based on the transparent models, which are the symbol of AIs or very old rule-based methods, and opaque models that we are trying to use these days. One of the special features or approach, it is feature relevance based on the model-specific methods. And we can see three dominant XAI models that can generate visual explanation. The importance one for medical healthcare, it is heat maps. How can we generate heat maps to represent the decision come out by the black box of AI models? And also we have model agnostic methods. They can also generate some features based on different algorithms like LIME or SHAP. These two features also can give us more information, not just a decision of AI black box model. So, however, as we explained that the DARPA was the dominant for establishing something called XAI. So they start the work on this XAI based on the AI improvement and research continuously. And it is DARPA means defense, right? Defense. So it is a defense agency in USA, and they are always targeting the new things in XAI and AI at all to produce more information or more accurate models. So they start from 1960 till 2020, and then nowadays they have more advanced research. So this research is published in 2020. So because that they cut till here, right? So starting in the third wave, as you can see here, third wave, it is starting from 2019. And the heading for this wave, it is contextual reasoning. So contextual reasoning, that means we have to provide something beside the diagnostic decision came from the CNN or black boxes, right? So can we improve? The question was, can we improve the results for the black box? So that time for their project from May 2017 till April 2021, they provide the idea of explainable AI visually. right, visually, based on the heat map, saliency, or even SHAP as recently is published, right? So why they came to this wave? Because the second wave, it was a black box for them. So they were asking themselves why we have to trust the machine, why the machine give us always decision and we don't know what is that, based on what they decide this, right? So in that time, they start to think about XAI, and the medical healthcare start synchronously adopt the AI models to follow the XAI concept, as we are doing these days for research. So yes, based on the technology for the waves, third wave, so DARPA could introduce XAI in the project timeline, which is starting from 2017 till 2021. So, however, DARPA is a defense agency, as we say, Defense Advanced Research Projects Agency in USA, supported by USA, and this supporting it comes after the winter of AI, when the AI start to be declined, or the benefit of AI start to be decreased. So US and other countries start to give a lot of research fund to improve some kind of AI, because that nowadays we are in the revolution of AI based on LLM, right? So if we go through also XAI, we can always say that the third wave, it is accurate. It has accurate classification or prediction capabilities, and it has more explanation, not just the diagnosis results. So after that, something come up based on the LLMs. Usually, what we know about LLMs, it started from 2017 in parallel with this kind of XAI programs. So XAI programs, it started in the DARPA. They start to think in 2016, and they received the fund 2017 for 5 years, right? So in the parallel, Google was working for some models. It is called transformer architecture, which is the advanced model of BERT. So they have also published in 2017 the paper, which is very famous. Anyone know this? Attention is all you need. So from that time, they start to think in terms of projects, proposals, and conferences. And other companies start to also work and accelerate the research in this direction. So in 2019, OpenAI also introduced LLMs and start to get some significant attention with announcement of this company in 2019, and make it as a very general concept. And the first model was GPT with 1.5 billion parameters. So in 2020, also, they start to make more advanced technology for introducing the new models, GPT-3 and so on. So now we have many models, Lava and Lava 2.3, and Microsoft also come on the line to produce more LLM models as generative models to introduce some explainable things based on the questioning or dashboard or chatbots. Or, for example, questioning, answering for extracting some information for the input images. So on our side, we try to handle this based on the medical data that we have. So in 2023, also Gemini is introduced by Google as a new technology that can deal with different modality of like text, image, audio, video, and we can introduce it later. So our job here as a researcher, how can we integrate XAI output or outcomes with the LLMs that we are studying nowadays, and introduce some research about this technology. So if we talk about some conventional methods of machine learning, deep learning, there was nothing called explainable. So the explainability starts from 2020, and there is a very long future vision for accelerate the research in this area. And we need also some research, not just in the medical area, but also in different different fields to improve as much as we can. So the output always is come to our mind how to make the systems smarter. So the 2060 goal or final goal, it is for super intelligent AI, and that can a machine or a machine can think or thought like a human. So that is somehow tricky for the researchers, but always they are trying to do the best, and they have received a lot of fund in this area. So from 2012 till now, 2020, we can say we have individual handle modeling, even if they are hybriding for images, text, sound, and video, maybe separately or hybrid between 2 or 3 of them. But starting 2020, many people and start to talk about something called hybridization of sparse models. So these sparse models that they can deal with different modalities as an input data to generate the prospective outcomes, and this outcome is very rich, and it will give some important information for even doctors or users, patients at the end. So starting 2020, Professor Andrew Ng and Chief Dean, they start to talk about this kind of sparse models. And that time it was not announced yet, but they start to think how to make multitask models that can provide us multiple features as outcomes instead of a single model. So for example, a classification model can give you at the end, it is true or false, or maybe normal or abnormal, regardless on how many classes that we have for that task. But in that case, if you need to make another step for detection, you will generate more complexity for the AI modeling, and it will take time for the training purpose, even if for execution during the inference time. So they try now to think how can we make this modeling very general and introduce a lot of information. So we can receive, for example, classification, detection, segmentation, XAI heat maps, as well as that some text explanation or generate some text to explain what happened with this AI model. So such kind of multiple tasks that can be performed in unique pipeline, it will be great instead of integrate different categories of AI modeling together and produce complex AI modeling at the end. So nowadays, the direction of research is focused on how to integrate XAI based on vision encoder with LLM, right? So OpenAI, they are working together in parallel with Google to improve some LLM models, and some other researchers also working in how to integrate. Also Google, based on Gemini, they start to launch something called Mid-Gemini to focus on the application on medical healthcare. I will show you later in how to improve the XAI or AI technology to give us something vision, something textual, so that we can understand more deeper about the black box of AI model at the end. So here the input is 2 things, for example, image and text. And for image, we need some AI modeling to generate features. And these features at the end, it will have it will get some high level features, and these features will be combined with the textual based features, NLP based processing steps, and both vectors from both direction, from both paths or pipelines will be integrated and sent to the LLM. So here the question, LLM based on these probabilities from image as well as text, how it will introduce and produce some information regarding these probabilities, right? So LLM here will understand some features from vision encoder as well as text encoding outputs to provide us more explainable results, right? So here, for example, in this paper, there was some explanation or talking about the food, for example, right? So there is an input as image. So we are talking about image, then vision encoder. So for vision encoder, at the end, it is, for example, CNN that we know, right? So for this vision encoder, at the end, we can receive visual embedding vectors for feature probabilities, right? So it will be like in local language algorithms or global vision alignment. That means maybe CNN and VIT integrated together, providing us very accurate results at the end. So before we are working till here, we are thinking about the encoder vision if we have the input of images, right? But recently we are introducing something else. It is called LLM. So LLM needs some textual information, right? So this textual information is important, and it is our limitation in medical healthcare, because till now the most medical data published online, it has not text explanations for each patient. It is just medical image based. So, however, we need for textual also to collect data to represent the data, the patient information based on the doctor report at the end. So we can see this text also, it has some specific structure. This specific structure is designed based on the doctor or hospital. So it will be also there is a difference or various different architectures for these reports from hospital to hospital or country to country based on the medical protocols. So, however, in the term of text, we need some pre-processing for text tokenizer or text embeddings to embed this words to embed these words to be in the vector space as a text embedding or probabilities. So here we have part of visual embedding came from the image based, as well as we have text embedding came from the textual important information. So LLM here, it is his priority now, or it is his job to understand both embedding vectors from image and from text and introduce the comprehensive answer. So the comprehensive answer here, it will be in different forms. It is designed based on the researchers, how it should look like. So sometimes it is called question answering. So we have question like this about the image, then we will receive a short answer or long answer based on our prompts designing. Or it will be in terms of captioning to give a best caption for the input image, maybe. Or the best way it is to generate the whole structure of the report based on the different categories that we will design. So to generate such kind of very comprehensive report, we need to study very well the data set that we have from this data, and we need to prepare the data based on the prompt techniques to align the LLM to provide us very accurate information based on our data, not based on the general data that LLM is trained on. So this is the challenge, and we are working in this area. So, however, here we have some other things for LLMs. So LLM always trained based on the general data, and now we need to orient these LLMs to be and to generate data or textual data based on our used case. So to do that, there is something called RAG systems algorithms introduced to eliminate the hallucination for LLMs. Hallucination means not accurate text generated by LLM. So these RAG models, they are different techniques. We have different algorithms, multi-query and RAG fusion. We have decomposition technique and answer recursive fusion techniques. So these techniques, they are forcing the LLM to not give us general information because we cannot retrain them again. They are very huge models. So we will just try to orient the prompt question to give the proper answer based on our data set. So if we go back here, so this document, it is from our specific data, and we need first to embed this data in a global embedding database, what is called vector store or vector database. And then later on, when the user gives the question or query to the LLM, so we need first to design the prompt. So to design the prompt is based on what we need LLM to do for us. So in this case, for example, we need to generate a report, and this for the full detailed report need some exact information that came from only our data, not from the general information, right? So we have to follow this kind of techniques that we context query prompt designing for LLM models. So these the techniques that is used recently for RAG systems. So one of them is RAG fusion that we have applied in our research. It has presented yesterday in the IDAP conference in this sector, right? So here it is taking the question or a prompt from the patient, from the user, and divided inherently into multiple questions based on your designing. You can design multiple questions, and for each question there is some related documents from your database or vector database that you designed. At the end, they will gather all the documents related or textual information related to each question and inherently send to the LLM for giving some information. So these documents or this question, they are dividing and getting text-based information from our database that we have designed. So also in 2023, Biomed GPT was introduced from different researchers in the world. So we can say here, they said Biomed GPT could be more powerful in reducing some classification results, also some object detection results, as well as visual answering or reporting, right? So here we can see some heat maps for visual explainable, as well as some captioning results or some visual VQ answering, visual questioning answering. So the model, it should be very comprehensive to give us multitask or multi-outcomes based on the multitasks. So we need also these things in the medical healthcare, and it is important for us to improve the diagnostic information or giving recommendation for this, or to talk with the with the imaging or the images that you acquired from the patients. So you can ask, what is the diagnosis of this patient? Where is the tumor, for example? What is the size of tumor? What they recommend for healthcare or medicine for future, what is the prognosis things in future. So this information is very important in medical healthcare as well as in other fields. So it is very important for us as well. So in 2024, May 7th, also Google DeepMind and Google Research work on something called Mid-Gemini, that it is working based on the LLM models for medical applications. So they target many medical applications, and they have created data and collected data for these applications based on the image as well as text-based. So the LLM or Gemini, it is built on LLM based on the multiple features that can come from each modality, and the information here or the vector-based, it is came from the medical imaging text as well as. So they also introduce it will work for 2D images or 3D like MRI, CT scan, and so on. And it will give us very important outcomes for, they call it applications. So like, for example, explanation for example, outcomes for classification, VQ answering, reporting. So we are interested in these two things, which is based on the VQ answering and chat bot communication with the AI machine, as well as we have to look about the 2D generate report for the doctor, right? So these are our application these days. So maybe recently we can go through the other tasks based on the availability of the data set. So also Microsoft tried to introduce Biomed Parse, which is also chatbot based. They input the image and they ask some questions directly. LLM is involved internally, and it gives us some information based on the trainable process for that models. And you can see sometimes it gives us classification, sometimes it gives us segmentation based on that. right? So in our case, we are trying to also introduce some heat maps. So we have, for example, segmentation, classification, detection, XAI heat maps, as well as we have answering from the LLMs. So this is the research that is going on, and the journals start to ask about this kind of outputs as research outcomes. So in our case, we have this project between Korea and Turkey, and two universities from Turkey. They have supported by TÜBİTAK, and also here Korea University, Sejong University in our lab, AI Smart Solution Lab. We are working together to provide a comprehensive output in terms of detection, in terms of heat XAI maps, and in terms of textual explanation text reports, right? So we are working day and night, and last month we have conducted an international collaboration workshop there from Turkish professors. They came to us and we introduced our work and the medical data we shared to provide some kind of these details of an architectures, right? So also we have another example that is presented yesterday in the conference. It is based on the medical chest X-ray and respiratory disease prediction. So here we are trying to predict 14 different different respiratory diseases based on the chest X-ray images. This data, it is collected and annotated based on the experts to involve images plus plus text reports. And the text reports, they have some specific structure to generate at the end. So for text, we have to train LLM based on, or to build an alternative database. It's called vector database that can force the LLM to looking for in this data and generate information. So the output here, it is categorized based on the different categories. One is the LLM textual report. So we have different categories, and these are designed based on our thoughts, what the doctors are looking from each image. So we have designed this based on the prompt techniques and used the RAG system for a force LLM to generate some information related to our database for this medical data, not to just general or hallucinated data or information. And also at the end, we have some impression or recommendation at the org. Second, it is a disease classification, providing the class names and also the probability or class score. So the third one is the visual explanation based on the XAI GradCam models, as well as we have detection bounding boxes for these kind of images or tumor or respiratory diseases. And we will always indicate different views for explainability generation models based on the lateral and AB views. So this modality could be adopted and deal with different medical diseases, not just for the X-ray, but we choose this one because we have available data set yet. So we are looking for more data set in future. So we are dealing the collaboration with Firat University Hospital to generate such kind of text for medical data, so we can improve our data very well. So, however, the first step is to make data processing for both text and image accordingly, to receive something called vector database to ask LLM at the end to ask some information to generate. So for image processing, we have visual encoder. For text processing, we have text encoder, or we can say text factorization, as well as RAG fusion. So these two information, it is linked together. You can see here, it is linked together to import some information related to our database. So the text preprocessing, it will need some embedding models. We will use this model for embedding purpose for all text information to generate the vector database and then store in the Chroma or vector database. And later on, we will ask something, or we will use RAG fusion to directly give our information, based on these data vectors. And we will force LLM model to provide information based on this database, right? So at the end, we will ask a ChatGPT based on our question or prompt to give us the information that we need. And LLM will generate the data based on your prompt designing in the RAG Fusion model and prompt designing, right? So we have to think about the output, how it looks like, to provide some textual. So to provide textual as well as visual explanation is the state of the art for medical healthcare, and how to integrate LLM with the XAI modeling. So here it is also showing the conversion between AI think about the image, input images, and also the doctors that they can give us report in this way. So we are matching between these two texts and see what is the accuracy in terms of text explanations. In terms of visual explanations, we can see by our eyes and determine the boxes around this importance of these diseases that can happen with us. So these models will be deal with 2D or even 3D images with different applications, and also it is applicable for different fields of research. So if we see the future direction for this kind of AI, starting from symbolic AI till today, we have LLM and XAI. The question, it is still available. Is it possible to create an artificial brain? So our final goal is artificial brain. So it starts from 1921, that is introduced by Karel Kabik by using something called scientific fiction play, which is resumes universe reports, and it was just a question in general. Can we produce something smart? It will see the output. It will see by eyes like humans and give us more outcomes information, text-based, question-based, and also visual-based. So recently in 2024, Elon Musk also have introduced Neuralink, which is a wireless brain chip that can implement in the brain, in our brain, and start to talk about something that can happen around us, or special for disabled persons that can start to think about some actions, and it will give us outcomes to reflect the answer in our environment immediately. So I think they have starting implement, and one successful or two successful implementations for these chips has been successful done in 2024. So, however, this is our future. The challenge is, even if we have LLMs, the challenge is in how to provide some information or medical information based on the text report. So it is not easy to find such kind of information publicly these days, while we have a database in terms of images. So this is the big challenge for us. And also the challenge for textual-based or LLM-based, the models are very huge, and we need very strong PCs to provide more information. So to conclude our presentation, so the integration between XAI and LLMs in healthcare domain, it is to improve and trust the adaptation by clinicians, and also enhance diagnostic accuracy, reduction of bias in decision, assistance in the multimodal data analysis, training and collaboration with medical experts, assistance in multimodal data. Multimodal means text, image, sometimes signals, biosignals, or videos in terms of MRI or CT, for example, facilitating patients' communications with the users. So at the end, we will build applications in the term of user as well as term of doctor to communicate by themselves with these kind of AI models to provide them more information about the XAI modeling and some explanation in terms of textual as well as visual. So thank you so much. This is my presentation for today. So please let us know if you have any question regarding this seminar.
Thank you so much, Dr. Antari. We really appreciate for this great presentation. And I would like to ask my colleagues any questions.
Okay, that's great. Maybe I present very well, so no one would need to ask. So I just need to recommend all researchers to focus in these new areas for research. It is really interesting, and journals need such kind of research these days. So if there is no question, Professor Ahmed, I would like to thank you so much for your time and listening. And maybe we will see you in next year in 9th the IDAP conference, right? Professor Ahmed is here. I think Professor Ahmed, he is not available with us, right?
He just joined.
Yeah, he has some trouble in internet, I think so. Professor Ahmed Arif? Yes.
Yes, Professor. Sorry for the interruption. You know, we just had a connection problem. That's why.
I see.
Thanks for understanding. Sometimes, you know, technical difficulties happens.
Yeah.
You know,
No problem.
Okay, thank you. Thank you so much.
Yeah, no problem. I just was to talk talking about the recommendation at the end.
Okay.
Nowadays, we always looking for researchers to contribute in journal-based in terms of this XAI, LLM, and new technology for different fields, especially medical healthcare. Okay,
Yes.
so we will see you soon, inshallah, in Korea, or I will visit Turkey soon, and we will talk more, inshallah.
We are waiting. Both option is good, but when you come, this will be great for us. You know,
That is great.
as you mentioned in your presentation, you were our host in South Korea during the summer, and I think if you can come, you are gonna honor us, inshallah. This will be perfect, and then we can come again, and since our project is going on. And how
Yes.
about any questions about the presentations? And I would like to ask our colleagues to ask you questions if they have.
Yes, sure.
Okay. And you already explained a lot of important points. What do you think, Doctor, in the next, since you are one of the best and well-known researchers in the area of AI, I just would like to ask you about what should we focus on? Everyone in this room is also a researcher, and also you are our keynote. I just would like to ask again, what should be our direction in order to stay in the track in the AI research?
Yes, the best way is to follow the new technologies that it is very fast and rapidly appeared, right? So always these big companies or lead companies, Google, OpenAI, Facebook, Microsoft, they always introduce some ideas in general domains, and also sometimes they make it specific for medical healthcare. So we have to trace the trend and always accelerate our research. If we stay in the second wave, which is based only on CNN or Transformer, we will be late, right? So first point is to accelerate our perspective in terms of research, state of the art. Second is always to think about something called artificial brain, right? So it is the question that introduced in 1921. It is how to make our models more intelligent to come to the human response level. So this one, it will move up our intelligence and thinking in how to make these CAD systems end-to-end improved by itself.
All right.
Yes, Professor.
Thank you so much, Dr. Mugahed Antari. It was really our pleasure to having you in our IDAP.
You are welcome.
And
you are welcome. Thank you so much. Yes. So please go ahead. Yeah, please go ahead, and I am with you in this session. Thank you so much.
Okay. All right. You know, after 1 minute, our other sessions are gonna start. That's why I just would like to stop the recording, and thank you so much for the participants, and thanks for the questions, thanks for the listening, and I really appreciate for everything you have done until to this time.
Yes, you are welcome.
Thanks.
Thank you for your presentation, Mr. Mugahed. Dr.
Thank